All right, guys, so going to cover lesson 5.5 today. It's called the Rational Root Theorem notes. I just called it on Google Classroom the roots because we really talk about more than just the Rational Root Theorem. But anyways, that's what it's called in the textbook. But we're talking about roots today. That's one of those words that a lot of other words mean the same thing, right? So solutions of an equation are roots. What else are they called? X-intercepts, right? We can find them on the x-intercept. Zeros, right? Roots, all those kind of four words pretty much mean the same thing to a certain extent, right? All right, so then our learning target is I can find the possible rational roots of a polynomial. So that'll be example 1. And then use the conjugate root theorem to basically produce a polynomial given its roots. And we've done problems similar to that, but with like rational number roots. We're going to be dealing with uglier roots today. All right. So this rational root theorem is really going to kind of come into play maybe on the next lesson more so than on today's. But the big idea is that whenever a polynomial is not factorable, you could use the rational root theorem to solve for the zeros. And that's kind of true. It's not totally right. So what the rational root theorem does is basically give you any possible rational number solution given that equation. Okay. So like, what is a rational number? What does anybody know? Kind of the mathy definition for a rational number? It's any number that can be written as a what? Fraction. Okay, any number that can be written as a fraction. So that could show up as a simple thing like an integer, -5, +2, right? Stuff like that. It could show up as obviously a fraction can be written as a fraction, and then any decimal that terminates or repeats. Okay, so those are rational numbers. Okay, all right. So how do we find all the possible rational roots given an equation? So there's this P over Q deal. So basically that's how we find them, as P over Q. So what is P and what is Q? So P is, it says on the notes, last coefficient. Usually that's really a constant. You might want to note that. That's typically a constant, right? That's usually what's at the end of our equations. And then Q is the first, or the lead coefficient. And specifically, like you're looking at the last coefficient and the lead coefficient, but what about them? It's all of the whole number factors of both, or the integer factors of both. So let's just say factors of each. All right, so let's go ahead and find all the possible rational roots for each equation. And understand this. These are not all the roots for the equation, and you'll see why it doesn't make sense at the end that it would be. It's just any possible rational root based on it's starting with a 15 and ending with a 2. Okay? All right, so let's go ahead and remind ourselves that it's P over Q. Okay, and numerically, we're thinking about the number 2 for P and the number 15 for Q. More specifically, we're thinking about all of the integer factors of each, right? So that's going to be for 2, 1, and 2, right? And it's every positive and negative version. So to be technically correct, we'll say plus or minus 1, plus or minus 2. All right, and then 15. How many ways can we break down 15? 1 goes into 15. Sorry, 1 goes into 15. 2 does not. 3 does. So plus or minus 3 as well. 4 doesn't. 5 does. 6 doesn't. 7 doesn't. 8 doesn't. What's the last one going to be? 15. All right, now, what do we do with all this? Okay, it'd be nice if we could just leave it like that, but we want to actually list these out, right? So to kind of assign each numerator to its denominator, that's how we do it. We just go 1 over each of the bottom, 2 over each of the bottom. So it ends up with, 1 plus or minus 1 over 1, which is 1, plus or minus 1 over 3, which we would just leave as is, plus or minus 1 over 5, and 1 over 15, plus or minus 1 over 15. And then you just do the same thing with the 2. So 2 over 1 is 2. Then we have 2/3, 2/5, and 2/15. A lot of times you'll have repeats within your fractions. In this case, we don't, right? We have 2 factors in the numerator, 4 in the denominator. So if we kind of use the counting principle, it makes sense that if we counted those, we would have 8 factors, right? If you counted all of what we just listed, that's 8, really 16 because you double that. But those are all the possible rational roots. Now, before we move on, like how many roots could our equation have? If we tried to solve for x, how many roots would it have? Just based on the equation that starts with 15x cubed. Anybody know? What's x cubed tell us? How many roots could it have? 3, right? It would have 3. So it wouldn't make sense that all 16 of these are actual roots, right? It may be the case that none of them are. It might not have any rational roots, but based on the 15 and the 2, those are all the possible rational roots. Anyways, you go ahead and try B, get as far as you can in about a minute and a half, and then we'll kind of compare at the end, okay? All right, so again, we end up with, kind of a similar situation as the last one, except we had more on the numerator than the denominator. We have 4 factors up top, 2 on the bottom. So you would think that would lead to, if I'm reading what's in black at the bottom in my final answer, you would think that would lead to, 8 plus or minus kind of situations. So why, when I count them, 1, 1/2, 2, 3, 3/2, and 6, why are there only 6 and not 8? Where'd the other 2 go? Yes. 2 of them are repeats, right? So once I got to I'm trying to find the first repeat. Yeah. What is the first repeat? Oh yeah, 2 over 2. I didn't list that as 1, right? Because I already had 1. So there's a couple repeats in there, right? So this one has 12 possible rational roots. Okay. Doesn't mean that any of those are the roots, right? We could solve, but those are all the possible rational roots, right? So if you got an answer of 7, that's wrong, right? That's not possible. So anyways, I don't find this honestly to be super useful, but that said, there is one on the test where you have to list out all the possible rational roots. So, learn it if for no other reason than for that. All right, now we'll get to the slightly trickier part of this homework, of this lesson, I guess, the conjugate root theorem. So it's this, the big idea is, and I'll put it where there's a little space here. Here's what we kind of want to remember. It's all kind of based on this a squared minus b squared equals a plus b times a minus b idea. Think about on your last test, like we had those problems where you had to simplify like a fraction that had an imaginary number denominator. It's that kind of idea, right? But basically what it says is this: if you have a number a plus the square root of b, if that's a solution, then its a minus b counterpart would be as well. So that would be a minus the square root of b. And we haven't seen that yet, but you do treat irrational numbers just like you would imaginary numbers. So irrational, imaginary get treated kind of the same way. And then if a plus bi is a solution, then so is a minus bi. Irrational, imaginary get treated very similarly in this way. Okay, so on example 3, what we're trying to do is say, if this is a solution, then what else has to be, or does anything else have to be? So if 6 plus the square root of 3 is a solution, then by definition, 6 minus the square root of 3 has to be, because that's an that's an irrational number, the square root of 3. If 0 minus the square root of 5 is, then so is 0 plus the square root of 5. So square root of 5. And what about 4? Is 4 irrational or imaginary? No, it's not, right? So so this doesn't have, it doesn't necessarily mean that -4 is also a solution. So I would just say none on that one. That's a little curveball there. All right, so you guys tried D, E, and F, or I guess we could call it G. Where the F did it go? That was a reach. Also slightly inappropriate. Forgot I was making a video. Sure. All right, so I went ahead and wrote them in. We'd have 5 plus 7i to go with 5 minus 7i, -3i to pair with 3i, and then sometimes G could be a little bit confusing there, because like, do I flip the sign on the 5 or don't I? You don't, right? It's just for that B part. Okay, is everybody with me on that? Anybody have any questions or anything? All right, very good. Now let's get to the slightly trickier stuff. Okay. And I'll try to say this a couple times, but on your homework for this lesson, the 5-5 Math Excel, there are 7 problems on there, I think. Anyways, number 3 and number 6 are both treated as bonus problems, okay? So you only have to do 2 less than however. So if there are 7, you have to do 5. And if you do 3 and 6, then you get bonus credit. And if anybody's interested, I can show you how to do those. If not, then you can just ignore them, okay? Which might be wise as we're kind of rushing to the end. But you could get a couple bonus points if you want, okay? All right. So example 4, write a polynomial with rational coefficients that has the given roots. And this is how they're going to show up on a test, right? Let's skip A for now and come back to that and look at B. So it's just going to say your polynomial has the root 5i. It's going to be your job to know that if 5i is a root, then by definition, so is -5i. We can't have a 5i without a -5i. That doesn't make sense, okay? But it's not, they're not both going to be listed, right? That's going to be part of the question. All right, so if both of those are roots, then we think what factors produce those roots, right? So now we're going to start to get somewhere. So we'll have y equals You know, what factor produces this root? That would be x minus 5i. And what factor produces this root? That'd be x plus 5i, right? Everybody with me on that? We've looked at similar stuff to this before. And what do we do at the end? You know, this is technically correct, but we want to write it in standard form, so we multiply it out. There is a shortcut anytime you do these conjugates, right? A squared minus b squared. That's how I'm going to show it. If you don't like that shortcut, just multiply it out, right? Distribute the x, distribute the minus 5i. So I would say you show it your way. I'm going to show the shortcut, which would be the first term squared minus the last term squared. So x squared minus 25i squared. And that's a decent answer, but an unsimplified answer. What's my simplified version of that answer from the last test? X squared plus 25, right? That I squared we remember is -1. And if you didn't remember that, probably put a note about it, right? I squared equals -1. Anyways, yeah, our final best answer would be x squared plus 25. And again, that's kind of an easy one to confirm because, you know, if I told you, if I gave you x squared plus 25 and told you to find the zeros of that or the x-intercepts, we could just plug 0 in for y, move over the 25, and we'd have -25 equals x squared. So x equals the square root of -25, which is what? Plus or minus 5i, okay? So anyways, we can see that it works. All right, so let's look at A, which we're not going to work all the way out. A is more like one of your bonus ones, actually even a little bit tougher, okay? So let's go ahead and first start with name our additional roots. So it lists 3. There should be 5. So what's another one that's missing that's not listed? Somebody give me another one. 3 minus the square root of 7. That's right. That's one of them. All right, and then there's one more that's not listed. Anybody else? How about somebody in the middle row? Give me it. Yeah. 4i. Very good. So this one really has 5 roots. It showed us 3, but it really has 5 by definition, right? So let's go ahead and list them out. Let's come back to the 2/5 and focus on the other weird stuff first, okay? All right, so these two right here that kind of are paired together, their roots would be, you know, it's a little more confusing than it looks, but hopefully this makes sense. Here's basically how you would set those up. I'm going to leave a little space for the 2/5 one. Start here. So you'd have x minus what I have circled. So x minus 3 plus square root of 7. And then x minus 3 minus square root of 7. So that is a really funky looking deal, right? You could see why that would turn into a bonus question if you thought about multiplying that out. Which, like I said, if anybody's interested at the end, I can show you how to do it. All right, let me make some more space. All right, and then I have these two here, which have a little bit less going on. So I would have x plus 4i that would produce -4i, and x minus 4i that would produce positive 4i. So there's 4 out of my 5 factors. Now, if you had on this, don't write this out yet, but if you had x minus 2/5, that's a good thought. But a lot of these say with a lot of the, like a Math Excel won't accept that. So how can we write that with like integer coefficients? So basically, I think the easiest way to think about this is kind of reverse engineer it. But you could also think about it as we're going to times everything by 5. So if we times everything by 5, then we wouldn't have a fraction. So what would that give me? 5 times x minus 2, right? X minus 2/5 is probably fine, okay? It would just be easier to multiply this way. Anything that you would have to multiply that looks like this would be like more of a bonus type situation. If you did do the bonus, one tip I would have is that you would tackle these two together, and you would tackle these two together, and then go from there. And that would be a beast of a problem, okay? It just would. But the rest would be like bonus, okay? So we're going to skip it for now because your eyes are going to glaze over if I work all that out, all right? I'll do that upon request at the end. So then let's go ahead and I'll leave you C to try. Let's go ahead and set up D, and we won't work all the way through it. All right, so if 1 plus 2i is a root, then 1 minus 2i is a root. If negative 3, square root of 3 is a root, then positive square root of 3 is as well. So here's what I want you to do over the next few minutes. Get as far as you can. It says on B and C, we already kind of did what we were going to do on those. Try to work C out all the way through if you can, because that one's a little bit easier. We've already done one like that. And try to just set up the unmultiplied equation for D. All right, and then we'll kind of compare in about 3 minutes. And work with each other on this, right? If you're confused, you're not the only one, I promise. Reach out for some help there. Tell it's been a while for Granny and Papa since they've watched our kids. I got 18 texts already, and these are all going to be pictures, but they get a little amped up on their Friday mornings. So if you need a little help on what I wanted you to do on D, I actually just wrote it up there. C should be, pretty easy to multiply, I would say. I'm going to start doing that. And you can check whatever you're ready to check. Sorry, that's not right, is it? If you were looking at C there, I did one of them wrong. That should be an x plus 10 at the end. So sorry if I screwed you up there. All right, so what maybe you were able to get done with, or just check whatever you did, was write out your roots for C and D, or sorry, your factors that produce the roots. So x minus 7 and x plus 10. I had initially wrote that down wrong, so if you copied that, just make sure you have it fixed. And when we multiply, we end up with y equals x squared plus 3x plus minus 70. That one would be a pretty easy one to check, say if this were a test question, we could just type it in real quick, x squared plus 3x minus 70. And then we're just looking, does it cross at those two x-intercepts, right? So you can kind of see there on the side, it would probably go through -10. You may want to zoom out there. And 7, we can definitely confirm in a table, right? So if we go to -10, we see that -10 goes to 0, and then we scroll all the way to 7. We can see that it goes to 0 as well, right? So we did the right thing there, and that's not too bad to check. Checking one of these other ones, you have your hands full. Anyways, the other part was, if you got done with C, were you able to write out what I did on D? So double check all of that. So we have x minus your 1 plus 2i and x minus your 1 minus 2i, right? So notice this is where the sign switch is within our imaginary number itself, and then the other one's a little bit easier because it didn't have like a rational number part, right? So just x plus the square root of 3 times x minus the square root of 3. Now, I went ahead and posted your homework. You guys feel free to tune me out on this last part, but I'm going to show how you would get those bonus points. If you're interested, keep watching. If you're not, go ahead and get started on the homework and just kind of you could try to figure out 3 and 6 on your own. You could just skip them. But if you're interested, I'm going to show how to multiply something this beastly out, just so it's on the video, okay? Feel free to tune me out and do your own thing. All right, so here goes. All right, so if we want to do like a bonus question here, you're going to have to keep the right things together, right? So you're going to look at these as a pair and these as a pair, right? Because if we start trying to do the imaginary with the irrational, we're going to end up with a whole nother can of worms, okay? So let's start with what's maybe the easiest, okay? This is almost like it's a multi-step problem, So if I look at this would be, to me, the easiest part of this question. So x plus square root of 3 times x minus square root of 3. And it's easy because we can kind of use that shortcut, all right? You don't have to use the shortcut. You could distribute both terms. If I did use the shortcut, though, I would have, the first term squared minus the second term squared. And then, so obviously x squared is x squared, fine. Then what is the square root of 3 squared? When you square a number under radical, it just gets rid of the radical. So it's just 3. So x squared minus 3 would be that part, okay? And I'll come back to that here in a second, okay? Now, what about this other thing? X minus 1 plus 2i times x minus 1 minus 2i. All right, let's see what the best way to explain this would be. Okay, I don't think using a shortcut is necessarily wise here, okay? I would more just multiply it out, right? So take x times that whole second binomial, right? So at this point, I'm going to start by distributing this term right here, okay? So when I take x times, x, I get x squared, easy enough. When I take x times -1, not +1, but that's -1, I get -1x. X times plus 2i, that would be plus, let's just call it 2ix. That's what's going to cancel at the end. And now I'm going to distribute my -i minus 2i term, okay? So that would be -1 times x is just -x. -1 times sorry, negative 2. I think about the best way to do this. Yeah, then I would take negative 2i times x, and that would be negative 2ix. Like I said, that's just going to cancel out with that, okay? So we can pretty much forget about that. And then the last thing we have to do is take this times this. And so how do we do that? That's where you want to kind of use your a squared minus b squared. So this is real. It is not easy, but anyways, that would be plus 1 squared minus 2i squared. So I'm going to bring that down a level. So we have x squared minus 2x, just kind of combining like terms, plus 1 squared is 1, and then minus 4i squared. And then I just simplify 4i squared, right? I'm just going to change that to a plus 4 and combine like terms. So my final answer here would be y equals x squared minus 2x plus 5. I guess this is not my final answer. But, and then I still have that x squared minus 3. Okay, there's nothing really new with that, so I'm going to cut the video off there. You would still have to go ahead and multiply all that out. But anyways, what's in green is new. It's not easy. It's tough, right? You might look back at the video and still think, I don't know what this guy's talking about. And you wouldn't be the only one because it is tough. So that's why it's bonus. Not going to be on your test unless it is a bonus question, okay? So there you go. If anybody has any Math Excel questions who's gotten started, I'm happy to show more to you guys. Hopefully this helps.